Alright, let's solve another rational equation with polynomial denominators. So we have x over x minus 3 minus 7x minus 6 over x squared minus x minus 6 equals 2 over x plus 2. So again, the denominators have multiple terms in each one of them. Therefore, we're going to follow these steps, which basically is just an additional step of factoring. So first step, like before, put non-fractions over 1. However, all of these are fractions. So we can move on to the next step. Next step is to completely factor all expressions, especially the denominators. So let's go ahead and factor that middle denominator. We can use the x method. It's going to be x minus 3x plus 2. I've gotten to the point where I can just look at it. However, if you were curious about what that x would look like, you would have a negative 6 on top and a negative 1 on the bottom. So there would give you, therefore, did I do that right? Negative 1 on the bottom. Excuse me. Okay, so that means you have a negative 3 here and a positive 2 there, which is how we got to here. Okay, so we can already allude to the fact that our LCM is going to be x minus 3x plus 2. That will ensure that all our denominators can be equal to each other. Again, that's called the least common denominator. It's going to be x minus 3x plus 2. So then we're going to turn all the denominators into the LCM. We're going to multiply the left by x plus 2 over x plus 2. The middle is good. We don't have to do anything to that. The right only has an x plus 2, so we have to multiply it by x minus 3. Alright, so we did that to the top and bottom. And guess what? Now we're going to go to step 5, which is my favorite step of just crossing the bottom out and setting the numerators equal to each other. Okay? That's exactly what we're going to do with step 5. Now we just have to focus on the numerator by combining these basically. Now, this is going to be a quadratic function because it's going to be x times x, but that's okay. Now I've shown arrows here to indicate that yes, we need to distribute this minus to both of these terms. So the negative 6 will become positive 6, and we will also distribute this x, so it will become x squared plus 2. Here the 2 will distribute to this, so it will become 2x minus 6. Alright, so that's exactly what I just talked about. And once we do that, we can see that we're going to have a 2x here and a 2x there. They are going to cancel. We're going to have x squared minus 6x plus 6 equals negative 6. I don't know if I showed that work there. Yes, I did. Okay. Step 7 is to solve. You know what? That was kind of all of step 5, so let me just change that real quick. Maybe we'll call this step 6. So step 6 is to solve. Step 7, of course, is the check by plugging in, checking for extraneous. So to solve this, I need to move everything to one side since we have different variables with different exponents. I'm going to subtract 2x, add 6 to both sides. We get x squared minus 7x plus 12 equals 0. We're going to use the x method here. This is going to factor down to x minus 3, x minus 4. Again, for those of you who need some help on that or want to see the x, the top of the x would be 12. The bottom would be negative 7. The sides of the x would be minus 3, minus 4. Okay? So once we do that, we can set each of these factors equal to 0. We get x equals 3 and x equals 4. So now we're going to take these numbers for step 7 and plug them back in. Okay? So let's go ahead and do that. When we plug in 3 into the original equation, we get 3 over 0 here on the left, so again that's going to be an extraneous solution. However, when we plug in 4, everything checks out. We end up getting 2 over 6 equals 2 over 6, or 1/3 equals 1/3. So x equals 4 is the answer, x equals 3 is an extraneous solution. That's it for this example of solving rational equations involving polynomial denominators. We will do one more example in the next video, maybe more after that. But anyways, if you have any questions about this example, let me know.